Motional EMF. So now see how the motional EMF develop and what is the cause of induced EMF. So this is a conductor. Let conductor your PQ, and this conductor is kept in magnetic field which is directed inward. So we are assuming the field is directed inward like this. And conductor is moving with velocity v. See the very interesting point here. As conductor start moving rightward, so we know each of the conductor have free electrons. So due to the effect of motion of the conductor, these electrons also have a net velocity right side. So when a charged particle moving in a magnetic field, that charged particle experience magnetic force. So force on a charged particle, force on electrons inside a conductor is given as F is equal to minus E V cross B. This is the magnetic force, so we can say that here Fm. Now, due to effect of magnetic force, let this is one of the electron. So that electron having velocity in this side, the force on electron will act in the downward direction. So magnetic force on electron is here like this here in this direction. So as magnetic force start acting here downward, and so at this point here polarization of charge will be there. So here at one of the end negative charge density or increases, and at the other end positive charge density. Relatively two ends of a conductor will be at different charge density. So due to the presence of this positive charge density here and negative charge density here, an electric field within the conductor develop. This is the direction of electric field. Due to effect of electric field, a magnetic opposite to magnetic force, one electric field also develop. So let at this point here, when conductor reaches here, at this position here, positive charge density here, negative charge density, electric field and force in this side and magnetic force in this side. So due to polarized charge, an electric field developed inside a conductor. An electric field developed inside a conductor, and that electric field apply force on electron. That electric field exert force on electron opposite to direction of magnetic force. Opposite to direction of magnetic force. So this process continue. It means magnetic force and electric force start acting here. But Magnetic force value will remain constant because neither we are changing the V value nor magnetic field. So magnetic force remain constant, but electric field, as electric force is given as Q into E. As electric force is given as Q into E, so as the more charge accumulate, so more electric field develop. So one stage will come, the force on electron. One stage will come and force on electron is equal to force on magnetic force on electron. So at one stage, net force on electron will be zero. So further polarization of charge stop. Then electric field electric field inside a conductor become constant. Constant. So we can write at equilibrium, F magnetic plus F electric is equal to 0. So F magnetic your this minus E V cross B, and F electric your minus EE is the 0. So that gives us relation between E and V. So minus V cross B. So this is the relation. It means when the electric field value is equal to your minus of V cross B, then the equilibrium will establish. Now, as potential difference as dV by dr is equal to your minus E. So we can write here n cap. We can write here dV is equal to your minus E dot dr, and E value we are having this. So it becomes your V cross B dot dr, and this gives us potential difference between any 2 points. And in expanded form we can write dV is equal to your VB sin theta into dr cos alpha. This is the expanded form of the potential where theta is a angle between V and B, while alpha is angle between V cross B vector and dr vector. So this is the general expression of calculation of potential or EMF, and this is the cause of EMF, why the EMF generates, why the potential difference generates. That is because of the polarization of charge. Now see how we can use this relation and how we can get the polarity. So from here it is very much clear. The terminal or the end where positive electric field is acting, that end will be at higher potential, and opposite end will be at lower potential. So see the calculation of EMF by using this relation. So as induced EMF is written as V cross B dot dr, or we can say VB sin theta dr cos alpha, where theta is angle between vector V and B, and alpha is angle between vector V cross B and dr. Likewise, see how to calculate this. So first case, induced EMF due to motion of straight conductor in magnetic field. See, suppose this is your conductor of length L and it is moving with velocity v in uniform magnetic field B. The same way we can use C. And another way is that how to get the polarity. For polarity we can use the direction in which electric field is there. The electric field direction is the direction of V cross B. So in the direction of electric field, in that direction your positive charge will go, that terminal will be your at higher potential. See, the PQ is a conductor and we want potential difference. So between P to Q if we want, so just take a dr distance here, from here r. So how much the induced EMF in these two? dE is equal to V, velocity over V, magnetic field B, theta. Theta is the angle between velocity and magnetic field. Velocity, this magnetic field inward, sin theta means here sin 90, dr. Dr we are going in that side, dr in this side, and cos alpha. Alpha is the angle between V cross B. V cross B direction your upward, but dr your downside. So angle between this your 180 to cos 180. So dE minus VB to dr. Now we can integrate r value from 0 to L. When r is 0, at that time point is the end of point P. And when L, so this is another Q, EQ. So this can be written as EQ minus EP is equal to minus VBL, or simply we can say VP minus EQ is a VBL. So induced EMF between the ends of conductor P and Q is given as VBL. Yes. Now see another example. Induced EMF due to irregular shape conductor, irregular shaped conductor moving in uniform magnetic field. Uniform magnetic field. It means let this is your uniform magnetic field, an irregular shaped conductor like this given. Let this is your PQ conductor and this is moving with velocity v. Now, so when we are following the same rule here, so see, we can take a small element. This element let dr1, somewhere here dr2, likewise, and all are moving with velocity v in the same direction. So total EMF E is nothing dE. So dE is what? According to this, V cross B dot dr1 plus V cross B dot dr2 and so on we can write. So here it becomes your V cross B dot dr1 plus dr2, likewise we can write. So E is nothing V cross B and dr1 plus dr2, this become your vector PQ. So dot PQ directly in that manner. So rather considering individual, in uniform magnetic field we can join ends of the conductor. So directly we can get PQ. Similarly, see, very interesting point here. If we are further, since this PQ is a vector, if further we are dividing this vector into two parts, let this your Q dash. See, so this vector we can write V cross B dot PQ can be written as PQ dash one vector plus Q dash Q dash Q. So total EMF can be said as V cross B dot PQ dash plus V cross B dot Q dash Q. See here. Now dot product. V cross B dot product. So first we will check the direction between V cross B and PQ dash. To see the direction of V cross B. V in that side, B in that side. V cross B. So direction of V cross B this. V cross B in this direction. So see, PQ dash and V cross B dash in the same direction. So angle between these two is 0. But Q dash and V cross B is your opposite direction, this 90 degree. So that is your 0. So finally EMF is only equivalent to PQ dash. So what is the main point here? That we can say whatever the induced EMF will be there, that EMF induced will be only due to that part of conductor which is either in the direction of V cross B or opposite to that, or your conductor direction should be along the V cross B direction. So induced EMF either we are looking from P to Q by curve path or directly P to Q or equal to PQ dash, that is same. It means Q and Q dash no induced EMF. The Q and Q dash point can be said as a same potential. So if it is your irregular shape conductor, so we can get like that.